Okay. 3, 2, 1. This is the movie Mistake Project for Physics 111. The movie our group chose to do was Saving Private Ryan. My name is Andrea Germanos.
I'm Graham Leonard.
And I'm Mans.
So, a little bit about Saving Private Ryan, the movie we chose to do. It was filmed in 1998, written by Robert Rodat and directed by Steven Spielberg. It stars Matt Damon, Tom Hanks, and Tom Sizemore. It won 5 Oscars, and it's one of the most accurate war movies of our time. So before we play the scene, I do have to warn you guys that this movie is rated R and there are soldiers being shot. So if you feel uncomfortable with watching that, please fast forward about 45 seconds. So in this scene, you'll see soldiers that are up on a ridge shooting M42 machine guns. They're shooting them down at US soldiers. These soldiers are approximately 6 feet tall, and the bullets are hitting their lower extremities, so their legs. This means that the bullet must be traveling at a minimum of 4 to 5 feet through the water. The bullets are traveling through the water at a certain velocity that we'll talk about later in the slides. And this scene shows that the bullets are killing the soldiers. So the purpose and goal of our project, the purpose was to prove that the bullets could not have traveled through the water at a certain speed to kill the soldiers. The goal was to determine at which angle the machine guns are fired from and the angle of the bullet entering the water. So to do this, we did some research, and to penetrate the skin, the bullets on which they were firing must be traveling at a minimum velocity of 45.1 meters per second. The most optimal angle for opening fire into water is between 30 and 90 degrees. A M42 machine gun, which they were using, fires at 755.904 meters per second. The height of the cliff from which they were firing at Omaha Beach is 30 meters high. The soldiers are 274.3 meters from shore, which is about zero point 0.1 miles. And machine guns can only fire bullets up to a few feet in water when fired head on.
So the first concept that we want to discuss when talking about these bullets is drag. Drag is defined as friction moving through a fluid. It's determined from the velocity of an object, the cross-sectional area, the density of the fluid, and the drag coefficient of the object. So bullets are made to be aerodynamic. So flying through air, they really don't experience a whole lot of drag, but as soon as it enters water, it's going to have a lot of drag on it and take away from its lethal capabilities. So the density of seawater is 1.0273 grams per cubic centimeters, and which is much greater than air. And the coefficient of drag is subjective to different circumstances. So it was hard for us to determine the actual drag on the bullet because we weren't able to have the actual bullet be shot into water from these circumstances. So without that coefficient, we're unable to actually solve for that for the force. And then in addition, drag is directly proportional to velocity. So the faster a bullet is going, the more drag it's going to experience when it enters the water. So guns that fire at super high speeds are going to lose their capabilities rather quickly because of the high velocity. Another thing that affects the bullet is the angle at which it enters the water. So depending on the angle, it's only it will project how far or deep it can move. So kind of like a diver that is on the right, he comes into the water at a 90-degree angle, which will have a more deep entry into the water on the y-axis, as opposed to the diver on the left. The angle is too low, then the entry will be flat, resulting in increased drag when entering the water and shallow glide depth, which means that the bullet can't travel, or the diver can't travel deep, but rather farther. So to put this into terms with the bullet, we took some values from the internet. We found the velocity, the mass, the depth of the cliff, the depth of the how far the soldiers are, and then we looked for the theta. So we started with the acceleration of each. In the x direction, we determined that in the air, the bullet has zero acceleration because it moves at the same constant speed. And then in the y direction, it has an acceleration of negative 9.8 meters per second. We then took this along with our givens and plugged it into a kinematic equation. In the x direction, we had two missing components, so we had to use substitution to be able to find the degree of which the gun was shot at. So we came up with an equation for time and then plugged time into the y direction. And then from that, we were able to find a degree of 6.1 degrees for the gun. Now that we have a theta for the gun, we're able to put that back into an equation and solve for time, which the bullet soared through the air. And after we found the time, we were able to solve for the final velocity of the bullet before it hits the water, which was negative 83.94 meters per second in the y direction, and then in the x direction, it was 751.6 meters per second. And then by taking the inverse tangent of those two numbers, we were able to find the angle of the bullet before it, or as it is about to enter the water, which was 6.3 degrees.
All right, so why this would not work. So Mythbusters actually did an episode on this, and they proved that water is basically bulletproof. They used a comparable supersonic bullet. It was shot 10 feet away into a pool, and it lost all of its velocity after 3 feet into the water. Upon the impact of the water, the metal jacket completely shattered into little pieces all over the bottom of the pool floor, and that was again after about 3 feet. So the bullet is non-lethal when even point blank into water. So even if you're right up there, it's still just going to shatter. So what exactly went wrong? The 6-degree angle is just too acute and would not have traveled 3 feet into the water. And the soldiers were submerged at a depth that was greater than the bullet would have been able to travel. So with the very shallow angle, the bullet is not going to reach the grown men, which were approximating to be about 6 feet tall. And they're being shot into their abdominal cavity and down through their legs. So that's a minimum of about 3 feet underwater. And obviously the 6-degree angle just is not going to be able to carry a bullet through seawater down 3 to 4 feet of depth and then actually into the soldiers to cause a lethal shot. So how could this have possibly worked? The angle of the gun needs to be changed. So we need to have it at least a 30-degree angle. And in order to do that, the soldiers needed to be significantly closer than they were. So they were about 270 meters away shooting into the water. And at that point, the bullet has gone through the air, entered into the water at such a minor angle, and then actually has to push through the water and then into the soldiers, causing the lethal shot. And so that just wasn't possible. So we would have to start with the guns being at a 30-degree angle, and then the depths of the soldiers needed to be kept at a minimum, so less than a foot submerged, if submerged at all, because the bullets do come to such a quick stop when they're underwater and fighting through the seawater itself. So in conclusion, it's impossible for the scene to be correct due to the projectile motion, the drag, and the depth of the soldiers. The drag also needed to be accurately depicted. So in the original movie, you can see the bullets flying through the water, and they're coming through at a speed that's similar to where they would come out of the gun from, and they're tearing into the soldiers, which obviously now through looking at the Mythbusters and the math, we know that that's not possible. So they would have to be much, much slower. Also, the optimal angle for underwater travel is between 30 to 90 degrees anyway. And even with that, the supersonic bullets aren't even able to travel more than a few feet underwater, even at those optimal angles. So being so far back, having such a shallow angle, and then having the soldiers so deeply submerged all of this, while this was such a well researched and well done movie, when you start to pick it apart, you can kind of see the problems within it, the physics problems. And so this was just one of the scenes that was unfortunately not accurately depicted. It was more of the Hollywood drama style. And so it's just impossible. Even though it was a really well done movie, this scene was not physically possible.
This is our works cited page in case anyone wants to look into where we got our information for. Thank you for listening.